Hello guys. So basically, we are trying to solve exercise 2C of relations and functions. But then before we start with the exercise, let us understand what are functions. Okay. So let us have a proper understanding about what are functions. Okay. So let there be two sets. I'm taking one example. A is the first set, B is the second set. Okay. So let there be some objects in set A. Suppose A, B, C, and in set B, let it be 1, 2, and 3. Okay. Now A is related to 2, B is related to 3, and C is related or mapped to 1. So this is one example which I am sharing with you. Now let us understand what is a function. Now first of all, a relation is a function if all objects in the first set, that is set A, are related. Now every object is mapped to some other object in set B, right? So it's a function. But then there is one more criteria. Now, when I say if we list down the ordered pairs, A comma 2, B comma 3, C comma 1. Okay. So the pre-images are A, B, and C. So each and every pre-image should have only one image. That means A should not have multiple images, B should not have multiple images, C should not have multiple images. So in this case, each and every pre-image in this particular example, okay, has only one image. So therefore it is a function. Okay, so both the criteria should be true. The first criteria is all objects in the first set, all objects in the first set should be related. Okay, and each and every pre-image or each and every first component should have only a single second component of a single image, right? So I'll just write down in short what is a relation, what is a function. A relation is a function if and only if first all objects in first set are related, and second each and every pre-image should have a single image in the second set. Okay, so these two criteria should be fulfilled. Now, is it so that any one criteria should be true? No, both the criteria should be true. Fine. So with this understanding, we'll take some more examples. Okay. Now let's take this example, set A and set B. Okay. Generally, the objects in the set A are X and objects in the set B are Y. Okay. So A, B, C. And this is P and Q. So, so now this particular example, if I have uh, written in front of you, it's not a function because all objects in the set A are not related. C is not related. Okay. Now let us understand this next example. Now, are all objects in the first set are related? Yes. Now this becomes a function. But then we have to check the other criteria also. Take a look at each and every first component or each and every pre-image. They have a single image. A single arrow is arising out of each and every object in the first set. So it is a function, right? Let's take one more example. Okay, so basically just look at all objects in the first set, that is set A. Are they related? Yes. All objects are related. Fine. So the first criteria is fulfilled. Now look at A, B, C, D, which are the pre-images. Fine. So from each and every pre-image, how many images are coming out? Only one. A has a single image, that is Q. B has a single image, that is Q. C has a single image, that is R. And D has a single image, that is S. So it's a function. Okay. I'll just modify this question. Now, is this a function? All objects in the first set are related. A, B, C, D, all are related. All are mapped. But then look at D. This time take a look at D. Okay, D is such that there are multiple images. D comma Q and D comma S. So D has multiple images. So it's not a function, this example. So let us go to exercise 2C now, which is in your textbook, page number, uh, chapter 2, page number 21. Okay. Now exercise 2C, question number 1. A is given as 1, 2, 3, 4. B is given as 1, 5, 9, 11, 15, 16. Now F, there is something that is called as F. So F has ordered pairs 1, 5, 2, 9, 3, 1, 4, 5, and 2, 11. Now the first question that these people are asking is F a relation from A to B? For F to be a relation in the ordered pairs, the first component should be from set A, the second component should be from set B. So let us check that. Okay. So take a look at the first components. Are this from set A? Yes. The second component. Are they from set B? Yes. So it's a relation. Fine. Now take a look at the second sub question. They are asking, is F the function from A to B? Now F cannot be a function from A to B because just take a look at object 2, which is the first component. Now 2 has multiple images or 2 has multiple second components, so it cannot be a function. Every first component should have a single image or a single second component. Okay. Second question. Question number 2. Now X is 1, 2, 3, 4. Okay. Determine whether whether or not each of the relation is a function from X to X. So the relation is a subset. The relation is a subset of X into X. So I'll just write down the first relation. Okay. So F 2, 3, 1, 4. Okay. 2, 1. Okay. 3, 2 and 4, 4. Right. This is F. Now look at the first components. The first components are 1, 2, 3, and 4. Okay. So set A 1, 2, 3, and 4. Set B, set of all second components. Second components are also 1, 2, 3, 4. If you observe clearly, 1, 2, 3, and 4. Right? Now 2, 3, 2, 1, 1, 4, 3, 2, and 4, 2. Right? Now all objects in the first set A are related. So the first criteria is fulfilled. But then look at object 2. 2 has multiple images. 2 has 3 and 2 has 1 as well. So this is not a function. Now while teaching, many teachers make error while teaching this particular problem. They don't draw the diagram and they mess it up. So you have to draw the diagram first of all, as per the ordered pairs given to us, and then only test for whether it is a function or not. Okay. Second, G, it's a relation. Okay. 3 comma 1, 4 comma 2, 1 comma 1. Now take a look at the first component. It is only 1, 3, and 4. Take a look at the second component. It is only 1 and 2. So 3, 1, 4, 2, 1, 1. Now some teachers might argue that why are you not putting object 2 over here, and why are you not putting object 3 and 4 over here? See, that is not the case. The relation is a subset of x into x. G is a subset of x into x. Okay. So all ordered pairs might not be there, right? So that's the reason why I'm telling you. Some teachers consider this to be wrong and they teach in a very wrong manner. Instead, what I would recommend is draw diagram for this. So we are ready with our diagram. All objects in the first set are related, and each and every image, each and every pre-image, sorry, each and every first component has a single image, single image or single second component. So this is a function. Okay. Previous example was not, but then this one is. Right. Third one, h 2 comma 1, 3 comma 4, 1 comma 4, 4 comma 4. Okay. Yeah. Let's draw diagram. A is a set of all first components. So 1, 2, 3, 4, as I can see. B is a set of all second components. So only 1 and 4. So 2, 1, 1, 4, 3, 4, and 4, 4. So all objects in the first set are related, and each and every pre-image, that is first component, has only a single image. So this is a function, right? Now let us go to question number 5. You can skip question number 3 and 4. We can just understand question number 5. Okay. Yeah. So basically, there are two sets given to you. Okay. So A minus half, 0, 2 by 3, 6 by 7, and 1. Okay. B minus 5, 0, 4.5, that is 9 by 2, 5, 5.5, that is 11 by 2. Okay. F of x, this is called as f of x is equal to 3 by x plus 1. And generally f of x is nothing but y. You should remember this always for the next 2 years. F of x is y. Okay. And what is y? Y is the object from the second set. X is the object from the first set. Just remember this. Now see, domain and range are the subsets of A and B. So domain is a subset of A and range is a subset of B. Domain is a set of all first components. So first components can be a part of A, will be a part of A. Okay. All or maybe few. Range. All these objects in B are a part of range, all or maybe a few. Okay. So list the elements of the function as ordered pairs. Okay. So we'll make use of this particular equation. Y is equal to 3 by x plus 1. So now they have given y is equal to 3 by x plus 1. Okay. So let's go back to the previous slide. Domain. Domain is nothing but set of all first components. First components are in set A. Okay, set A, and the values of set A are nothing but x. So all x values will lie over here. X values will lie over here. So the first value of x is minus half. So put x is equal to minus half. Y is equal to 3 upon minus half plus 1. So this is minus 6 plus 1. That is minus 5. So the first ordered pair is minus half comma minus 5. Now check whether minus 5, we got the value of y is minus 5. Is minus 5 a part of set B? Yes. So this is a valid ordered pair. So I'll just make a list of all ordered pairs. Minus half comma minus 5. This is the first ordered pair. Okay, it's a valid ordered pair. Okay. Now let us write y is equal to 3 by x plus 1. Put x equal to, take the second value of x. X comes from set A. So the second value is 0. Put x equal to 0. Y is equal to 3 by 0 plus 1. Not defined plus 1. So this is not defined. And not defined is not a part of set B. This is not in set B. It is not in set B. Okay. So we cannot write 0 comma infinity. This is not a valid ordered pair because infinity is not a part of set B. Right? Then y is equal to 3 by x plus 1. The third value of x. The third value of x is 2 by 3. So put x is equal to 2 by 3. Okay. Put x equal to 2 by 3. So y is equal to 3 upon 2 by 3 plus 1. So denominator will become numerator. 9 by 2 plus 1, which is 11 by 2. Now 11 by 2 is there in set B. It is there in set B. So 2 by 3 comma 11 by 2 is a valid ordered pair. Okay, so I'll just write it down. 2 by 3 is mapped to 11 by 2. Okay, then y is equal to 3 by x plus 1. Put x is equal to 6 by 7. The next value of x is 6 by 7. So we'll just put that value. Okay, y is equal to 3 upon 6 by 7 plus 1. This 7 will go up. So 3 into 7 by 6 plus 1. 3 1 the 3 2 the. So this is 9 by 2. Now 9 by 2 is a part of set B. Okay. So 6 comma by 7 and 9 by 2 is the next ordered pair. So 6 by 7 is mapped to 9 by 2. And the last value of x is 1. Okay. So y is equal to 3 by x plus 1. Put x is equal to 1. Y is equal to 3 by 1 plus 1. So the answer is 4. Is 4 a part of set B? Please check. No, it's not a part of set B. So we cannot write 1 comma 4 because 4 is not a part of set B. Remember, why we have to check it is a part of set B is because the range. Okay, that means the value of y should be a subset of B. It's given in the problem. See, it should be a subset of set B. But then 4 is not a part of set B. So we are having only 3 ordered pairs over here, which are valid ordered pairs. Okay. Question number 6, it is just for your understanding. All 4 statements mean one and the same. Right? Let us go to question number 7. Take a look at question number 7. A is equal to -2, -1, 1, 2. Okay. Now the ordered pair should be x and 1 upon x such that x belongs to 8. Okay. So we have to write down the range and domain, or domain and range, and whether it is a function or not, that we need to understand. Okay. Now see, x 1 upon x. Okay. So this 1 upon x is nothing but y. What are ordered pairs? X comma y, right? So 1 upon x is nothing but y. So I'll just write down y is equal to 1 upon x. So these are domain and range, and this is the ordered pairs. X comma y is the ordered pair. Okay. Now when we take x as minus 2, so 1 upon minus 2 is minus 1 by 2. So the first ordered pair is minus 2 comma minus half. When x is minus 1 upon 1, that is minus 1 comma minus 1. When x is 1, okay, y is equal to 1 upon 1, that is 1. So 1 comma 1, and x is 2. So y is equal to 1 upon 2, 2 comma half. Okay, so these are the ordered pairs. X is domain, y is range. Okay, and is it a function? Yes, because if you draw this particular diagram, okay, each and every object in the first set will be related. Okay, minus 2, minus 1, 1 and 2, minus half, minus 1, 1 and half. So if you are drawing this particular diagram, all objects in the first set are related, and each and every pre-image has a single image. So it's a function. Fine. Let us go to question number 8. Let us understand what they have given. So F has ordered pairs such that X is related to or mapped to highest prime factor of X. Highest prime factor of X. Okay. So first part of the problem. Find the range of the function where the domain is. So domain is nothing but values of X. So X belongs to 12, 13, 14, 15, 16, 17. Okay. So when X is 12, when X is 12, 12 is mapped to highest prime factor of 12. So just factorize 12, 2 into 2 into 3, right? So the highest prime factor is 3. So the first ordered pair is 12 comma 3. Then 13. If you factorize 13, it will be 13 into 1. So the highest prime factor is 13. Okay. 13 comma 13. If you write 14, 14 is 2 into 7. Highest prime factor is 7. So 14 comma 7. Right? Then 15. 15 is 3 into 5. The highest prime factor is 5. So 15 is mapped to 5. Okay. Then 16. 16 is 2 into 2 into 2 into 2 4 times. So the highest prime factor is 2. So 16 comma 2 is the next ordered pair. And the last one, 17. 17 is 17 into 1 and 17 is the highest prime factor. So 17 is mapped to 17. So we got the domain. These are domain numbers and these are range numbers. Okay. So we got the domain and range. Right. Now second part. Second part of the problem. They are asking you to write down 5 integers whose range is 3. Range is 3. Okay. That means this is range, right? This is domain and this is range. So highest prime factor should be 3. So what are those integers whose highest prime factor is 3? That we need to list down. any five integers. So first one is 3, the highest prime factor is 3, maybe 9. 9 is 3 into 3, highest prime factor is 3. Then 12, we can also take 12. Okay, 12 is 2 into 2 into 3, highest prime factor is 3. Okay, then 18, 3 into 3 into 2, highest prime factor is 3. 21 we cannot take because it is 3 into 7, that is 7 is the highest prime factor. Then 24, 3 into 2 into 2 into 2. So this is 24. The highest prime factor of all these numbers is 3. Fine. Next one, third problem. They are asking you to write a set of positive integers is s, and f of s is equal to s. Function of s is equal to s. So what are these integers? S are positive integers. So what is s? 1, 2, 3, 4, dot, dot, dot. So f of s is equal to s. Okay. So s is mapped to f of s. That means a number is mapped to itself. So in the context of this problem, the number and its higher prime factor should be same. Now, what is the highest prime factor of 2? It's 2. So both are same. 3, highest prime factor is 3. Now we cannot take 4 because the highest prime factor is 2. So both are not same. So this example is not valid. But then for 5 we can consider. 5, the highest prime factor is 5. Okay, then 6, the highest prime factor is 3. So we cannot consider this example. We want domain and range to be same. Both the numbers should be same. First component and second component should be same. So this is happening where basically? This is happening only in the numbers which are prime. So what can be said about the numbers they're asking in the problem? This is a set of positive integers which are prime. Okay. Let us go to question number 9. I hope everybody understood this problem. Question number 9. Yeah. What is the difference between a function and a relation? Now see, every relation is not a function, but then every function is a relation. And then what is a function? A relation is a function only if the two criteria which I had told you earlier, they are true. Fine. In relation, there are no such criteria. Okay. Yeah. So what we can do is we can take up the problem. Question number 9. X is equal to 1, 2, 3, 4. Y is equal to 1, 5, 9, 11, 15, and 16. Okay. See now. First one, A, F1. It is x comma y such that y is equal to x square, x belongs to x, y belongs to capital Y. Okay. So y is equal to x square. Okay, so y depends on x. So the first value of x is 1. So y is 1 square, which is 1. Second value of x is 2. Y is equal to 2 square, which is 4. 3 square, which is 9. And x value is 4. 4 square, which is 16. Okay. So is it a function? Yes, because you look at the ordered pairs. 1, 1, 2, 2, 1, 1, 2, 4, 3, 9, 4, 16. All objects in the first set are related. Okay, and every pre-image has a single image. Right? So it's a function. Let's go to second example. B. F2. It has ordered pairs 1, 1. So in the previous subpart, if it is a function, it has to be a relation, right? So it's both. Second part, 3, 1, 4, 15. Now look at the first components, 1, 2, 3, 4. Yes, they are a part of set X. Okay. Look at Y values. Y are the second components. 2, oh, sorry, 1, 11 and 15. 1, 11 and 15. Yes. So basically, these are from the set second set, that is set Y. So it's a function. C, F3, 1, 5, 2, 9, 3, 1, 4, 5, 2, 11. Okay. Now look at the first components. 1, 2, 3, 4. Okay. But then 2 is mapped to 9 and 2 is mapped to 11 also. 2 should have a single image, but then here 2 has multiple images. So it's not a function. Fine. D, F4, 1, 1, 2, 7, 3, 5. Now first of all, 1, 2, and 3. They are a part of set X. That's fine. 1, 7, and 5. Are they a part of second set, that is set Y? No, because 7 is not a part of Y. Okay. So this ordered pair is not at all valid. So it's not a function. Okay. And if it is a function, it has to be a relation also. So previous two examples, they were both functions as well as relation. This example B was certainly a function plus a relation. Okay. This example is only a relation, not a function. And this is function, relation, both are not functions and relation. Okay. So because 2, 7, now 7 is not a part of the problem itself. So it is neither a function nor a relation. Okay. Let's go to question number 11. Now, before we understand question number 11, we should understand this modulus of these two lines are called as modulus, absolute value function. Modulus of -3 is 3. Modulus of +3 is also 3. So in short, modulus removes the negativity. That's it. Don't make positive value negative. Right? So 11th one, domain of a function is a set of positive integers less than. Domain is represented with x. X belongs to positive integers less than 12. So what are the positive integers less than 12? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now y is equal to f of x, which is equal to modulus of x minus 4. So y is dependent on the value of x. Now when x is equal to 1, okay, y is equal to modulus of 1 minus 4, that is -3, which is 3. Okay. So the first ordered pair is 1, 3. Now when x is equal to 2, second value of x. Okay. Y is equal to 2 minus 4. Modulus of -2, which is 2. Second ordered pair is 2, 2. When x is equal to 3, y is equal to 3 minus 4. Modulus of -1. Modulus of -1 is 1. Okay. So likewise, you have to solve for each and every thing. And you have to list down the ordered pairs. The first ordered pair is 1, 3. The second ordered pair is 2, 2. Third ordered pair is 3, 1. Likewise, you have to list down each and every ordered pair. And just remember, for example, modulus of +2. It will be 2 itself. It cannot be -2. Okay. So this is how you have to write all ordered pairs for this function. Okay, now we have to understand one property, not a property kind of thing, but then we have to remember this as the formula. N of A is equal to P. Okay, N of B is equal to Q. So number of possible functions from A to B is Q raised to P, and number of functions from B to A is P raised to Q. So let us go to question number 12. Okay, x is equal to 2 comma 3. So n of x, which is P, is equal to 2. Y is equal to 135. N of y, which is Q, which is 3. So the number of functions from x to y, from x to y. Okay, so that is from A to B. X is as good as A and Y is as good as B. Is Q raised to. Okay, so it is 3 raised to 2, which is equal to 9. Fine. Okay, and had it been from Y to X, it will be P raised to 2. That will be 2 raised to 3, which is equal to 8. So this is how we. Thank you.